Okay, here we go. So I'm gonna, even though we have all these on our paper, I'm gonna move these up. We're gonna start with B down here, okay? So we have a slope of -1/5. Well, that's great. That's our M, right? And it says we're passing through this point. Fantastic. We have an X1, we have a Y1. Now it wants it in point slope form and function notation, right? We want both. Okay, well, if I have a point and a slope, can I write point slope form? Sure, that's all I need. I'm good to go. So remember, you can look back up at the top of your paper, but we're going to do y minus y1. Now that's going to end up being y plus 1, right? Equals -1/5 times x minus 2. Okay, so, and I'm going to write PS form. That's our point slope form. Okay, you do need to fix this. So it's y plus 1 equals -1/5 x minus 2. That is your answer for point slope form. I know every bone in your little math body wants to distribute. You see those parentheses, but then it wouldn't be in the form, right? So you have to leave it like that and put it in that form. Okay, next thing it wants function notation. Okay, so how do I go from this to function notation? Well, remember, function notation is just slope-intercept form. So all I'm going to do for this is rearrange it so I have y by itself on the left, and then I have it in slope-intercept form. I'll replace the y with f of x, and I'm good to go. Okay, so for function notation, I'll come over here. Function, how about that? Notation. Okay, I'm going to leave my y plus 1 over there on the left. I'm going to distribute this -1/5 through here. So I'm going to get -1/5 x, okay? -1/5 times -2. Remember, you just multiply the tops. It's going to give me +2/5. I'm just multiplying the -1 and the -2. 5 stays. Okay, one last step is I have to subtract 1. So I'm going to have y equals -1/5 x. And then I have 2/5 minus 1. Okay, so again, if you have the nice calculator that'll do that for you, you can put in parentheses 2/5, 2 divided by 5, put it in parentheses, minus 1, hit enter. Then you'll have to do math frac to get it back to a fraction. But otherwise, we can do that. We can do 2/5 minus, what can I change 1 to so it has a denominator of 5? How about 5/5? Remember that? You can make him anything you want. So 2/5 minus 5/5 is -3/5. That's what I have over here. All right, I'm not done. I'm in slope-intercept form now. I need function notation. So your next job is to replace y with f of x. And then you're done. And that's your answer. Okay, so even though, excuse me, these look like all you have to do is find the form, you have to be sneaky sometimes because you can't go right to the form, right? You have to go through other forms. So your best friend in all of this, 99% of the time, you are going to have to go through point slope. When in doubt, point slope, okay? And if you don't have a slope, you probably have at least 2 points you could use to find your slope. Okay, this also wanted to know, does this graph rise, fall? Is it a horizontal line? Is it a vertical line? So we look at our slope for that, and our slope is -1/5. So what's our line going to do? He falls, right? Or decreases, or whatever you want to say. Okay. There you go. Okay, everybody all right with that? That would be fantastic. I'll let you take a picture of that. Okay. Let's talk about graphing. You guys know how to graph, but again, we got to teach you this in every math class for the rest of your life, right? Okay, so here we go. Last page of section 2-3. So I always graph using slope-intercept form. If you want to do it a different way, you certainly can. You can find the intercepts. You can plot points. I don't know who would do that, but you could. Okay, so remember, you're going to graph your y-intercept first, then use the slope. Okay? All right, so here we go. First of all, what kind of form is that? Close? General, right? Because it's got a 0 on the right. So that is general form, okay? It's standard form if you have the constant on the right. It's general if you have the 0 on the right. Okay, we want to find the slope and the y-intercept with this guy. That's page 13. Okay, so here we go. Let's put him in slope-intercept form. So I'm going to add 56 to the other side. I'm just going to do this in one big step. I'm also going to subtract 7x. So I'm going to end up with 8y equals negative 7x plus 56. Everybody good with that? We want to divide everybody by 8. And I get a nice little negative 7/8 x plus 7. Okay, so we're in slope-intercept form because y is by itself on the right. All right, it wants us to find the slope. What is the slope of this line? You guys are knocking it out of the park today. Negative 7/8. Okay, notice I did not say negative 7/8 x. There are still some students who want to say x is part of the slope. It's not. It's not, okay? And then our y-intercept, you can either write 7, or if you want to make a point, you can make 0, 7. That's up to you. It doesn't matter. If my math lab asks for it, just read the directions so you know which one they want, okay? All right, let's graph here. So we graphed y-intercept first. So I'm sitting here and I go up to, I think that's 7 right here. It's kind of hard to see. We'll pretend it is. Okay, there's 0, 7. That's where I went. You don't have to label it. I'm just trying to be helpful here, okay? All right, then our slope is negative 7/8. So I'm going to start on the point, and because it's negative, I'm going to go down 7, but then I still go right 8. So I'm going to go down 7, and then I'm going to go right 8. And there's my line, right? So from here, I went down 7, and here I went right 8. You don't have to do that, just being a little helpful teacher here. Okay, there you go. Ta-da. All right, let's look at our next one. Okay, next one says, graph the equation x equals 6. Okay, this is where students get stumped because they're like, there's no slope. There's no y-intercept. I don't know how to graph that. Well, go to x equals 6. Here's your x-axis. Let's go to 6 right here. Okay, so if I want to make a straight line through x equals 6, where x is always 6, what kind of line am I going to have? Vertical. Yes. It's negative 6. Shalandra to the rescue. Okay, thank you. Only one that told me. All right, it's a negative 6. Thank you, dear. Okay, negative 6. Now we want to be negative 6. Still want to be vertical. There's our line. Ta-da. Okay, just so we know, because it does want the slope and y-intercept. Well, maybe it doesn't, but what would be the slope of this line? Anybody remember? Undefined. That's the one where the little slope guy tries to ski off and he passes away. He dies off the line, right? Undefined slope. Okay, does he ever touch the y-axis? No, so there's no y-intercept. No y-intercept. Your slope is undefined. Okay, awesome. All right, you don't have to worry about this guy here. This is just kind of showing you that you could use your graphing calculator to do this, but remember we kind of said we're not going to use that for this. So if they were to ask you on my math lab to use a graphing calculator to find the slope, they're not going to know. There's no graphing calculator police. What would the slope be of this line? -3. just write -3. They're not going to know how you got it, right? But there is a feature on there where once you graph it, you can kind of move your little cursor around and trace your line, and then you can come up with the slope by, you know, going up or down and left or right. But you already know what it is. Okay, let's move on to 2-4. Okay, so 2-4 is titled More on Slope. I mean, good gracious, right? But it's a little short equation, and 2-4 is all about perpendicular and parallel lines. That's why we have a whole nother section on slope. So we want to talk about parallel, perpendicular. The slope is the key to finding a parallel or perpendicular line. So that's why we're going to talk about it one more time. And then all we have is 14 and 15, just the front and back of this page on section 2-4. So he's a little short guy. So let's just start at the beginning here. What does it mean if two lines are parallel? What does that look like? They never meet. It's kind of like railroad tracks, right? Like train tracks or something. So they never, ever, ever touch. They stay the same distance apart the whole way, right? That's what they look like. What does it mean in terms of their slope if two lines are parallel? Anybody know? They have the same slope, okay? So if you have a line and you want another line that's parallel to it, guess what? You take the slope from the line you have and you put it in the next line and it'll be parallel. That's how you make a parallel line. You just use the same slope, okay? All right, what does it mean if two lines are perpendicular?
I know this one.
Yay. Oh, okay, that's how you find the slope. Very exciting back there. Okay, so that is absolutely true. Perpendicular lines mean they form a right angle, right? They form a 90-degree angle. So it's like if you had one like this, the other one would be right like this. So they would form this nice little 90-degree angle there, okay? All right, so they have a negative reciprocal slope to each other. That's their slope relationship. It's a negative reciprocal. So if you want to find a perpendicular line to one that you already have, you're going to do two things. You're first going to change your sign because we want it to be negative. So if your slope's already negative, the perpendicular slope's going to be positive. If your slope's positive, the perpendicular slope's going to be negative. Okay, second thing you're going to do is flip that fraction. Right? Change the sign and flip the fraction. Two things you have to do. Now that's going to be a test question. I'm going to give you a slope and tell you to find the perpendicular slope. And it seems like everybody knows you got to do something to it. So everybody will flip it. But then most students forget they have to change the sign too. So make sure you do both. Okay. All right. Little fun fact here, just because I think it comes up on my math lab. If you didn't see the picture, how would you find out? Well, that's a bad, I'll just tell you the fun fact. Never mind. Okay, here's the fun fact. If you multiply the slopes together of two perpendicular lines, if you multiply their slopes together, you get a -1. Okay, well, that's because they are negative reciprocals. But my math lab will ask you, I think, that question. So you want to make sure that you know that for my math lab. Yeah, for perpendicular, if you multiply their slopes together of two perpendicular lines, you get a -1. Okay, well, now we're going to play a little game called parallel, perpendicular, or neither. Okay, here we go. We have 3 here. They're not going to be all 3 choices. I didn't do that. Okay, so we want to decide, are they parallel, perpendicular, or neither? Well, as you can probably guess, you're going to need your equations in slope-intercept form because otherwise you can't tell. Well, I was nice to you. We start out baby steps. Look at this. We're in slope-intercept form. You know you're in slope-intercept form because you have y by itself on the left. Okay, so what's the slope of this guy? 5. What's the slope of this guy? 5. It's the same. So what kind of relationship do these share? They're parallel. Yay. Okay, it's easy as that. All right, let's try the next guy. Okay, now we need to be in slope-intercept form to find these. And they are. They really kind of are, right? Because technically, what form are they in? Function notation. Technically, they're in function notation, but we know that this equals y. So we don't have to change them. That's great. We're going to have to do some work on the next group. Okay, what's the slope of this first guy? -9. All right, what's the slope of the second guy? 1/9. Now, obviously, they are not parallel because they are not the same. Do you see that they are perpendicular though? You see that? Okay, so let's look. If we take the first slope, -9/1, all right, and I want the negative reciprocal of him, the first thing I'm going to do is change his sign. Then I'm going to flip him. And it just so happens that is the slope of the one below it. So they are perpendicular. No, nothing really to do. If you can see it right away, good for you. If you need to take one slope and transform it to the negative reciprocal to match it, go ahead. Now let's look at our fun fact. Okay, so what if we have a -9/1, because that's really what this is, times a 1/9. Let's see what we get. In the numerator, we get -9. In the denominator, we get a +9. That reduces down -1. Sure enough. Cool. Okay. Now we got a little work to do. Okay, we still want to know, are they parallel, perpendicular, or neither? We can't tell right now. We're not really sure because we have to put it in slope-intercept form, right? Okay, so let's take the first one. All right, I'm going to leave the 2y. I'm going to add the 10x to the other side. It's kind of hard for me to do that underneath it. So I'm just going to add him over. That's all I did is I added 10x over. Okay, let's divide by 2. And this is going to give me 5x plus 5/2. Okay. All right, let's look at this next little guy. All right, all I'm going to do here, now that's a -y, so leave him negative for right now. I'm going to subtract my 5x over. Okay, so it looks like that. All I did was subtract him over. I just did it, without writing it underneath over there. Okay, then if I divide everybody by -1, I get 5x minus 3. Okay, so now what's their relationship? Do they have one? Yeah, they're parallel. Now, sometimes they'll be super duper close. What if, let's go back up here. We said these were perpendicular already. What if this one stayed -9 and this one was -1/9? It's neither. It's so close, right? It's the reciprocal, but it's not the negative reciprocal, so it's neither. Okay. What if this was a +5 and this was a -5? Neither, right? Because they either have to be exactly the same or exactly the negative reciprocal. You can't have just a little bit of change. Okay. All right, last problem on this page. So write the equation for the line. We're still dealing with that. Function notation, okay, in general form. Okay, we haven't had to do a general. That passes through this point, okay, x1, y1, and is perpendicular, what in the world, to this guy. Oh my gosh. Okay, we got all kinds of stuff to do here. All right. Well, first of all, function notation is simply slope-intercept form, right? Okay. General form means everybody is over on the left and there's a 0 on the right, but you can't go right there, right? You can't just jump into that one. You got to go through like a back door and rearrange. Okay, so let's see what information we have. I have a point, a plain old point. So I don't have an intercept, okay? Do I have a slope? I kind of do. I kind of do have a slope. I have to find it. It gives me another line, and it tells me that I want a slope that's perpendicular to his line. So his slope is 1/5, okay? What's our slope going to be if I want it perpendicular? -5. So if he's positive, my slope's going to be negative. His fraction's 1/5. I'm going to flip that, and my new number is going to be 5/1, or just -5. So now I have a slope and I have a point. A lot of students want to use this y-intercept from this other line. Do I need that at all? No, forget he's even there. You're not allowed to touch him. You're not allowed to take him. He's for the other guy. Okay, so I have a slope and I have a point. Well, I don't want point slope form, but remember what I said, 99% of the time, what are you going to have to go through? Point slope form. So we got to get an equation, then we can rearrange it any way we want. So here we go. We're going to go y minus y1. It's going to end up being a +4, right? Equals our slope times x minus 9. Okay, that's point slope form. I don't want any part of that, but let's fix him. Okay. Oops, and you're distributing a -5 through there. Hold on, I just completely lost all my math skills. Okay, there we go. All right, so let's do function notation first. So if I want function notation, I need to solve for y. I get y equals -5x plus 41. Okay, then I'm going to clean it up and call it f of x. This is my function notation. Okay, I had to go through point slope. You almost always do. Okay, now I want general form. So remember, general form means I got to move everybody to the left with a 0 on the right. Okay, so I'm going to go back to where I had this, back when I had a y. And I'm just going to scoot everybody over. So I'm going to add my 5x. And I'm going to subtract my 41. And I'm going to get 5x plus y minus 41 equals 0. And that is general form. Remember, general form means no fractions. And it means that the x term is positive, and it is. So I don't have to rearrange, I don't have to do anything. No fractions, and your x term is positive, so we're good. Okay. So that one was pretty tricky. That's the kind of trickiness you're going to get. So just make sure it's not enough to just know the lines. You have to know how to get there. You have to know how to weasel your way into a line based on the information they give you, even if what they give you is information about another line, right? Okay, so that brings us to one last problem on here. We're going to see if we can get through it. Okay. Everybody good if I turn here on the page? Okay. All right, last one. He gets his own page because he's a little long. We need a lot from him. Okay, write the equation for the line in point slope. Whoops. Okay, we can do that. Then slope intercept form. We can do that. In general form, good grief. Okay, we can do that. We have a point, x1, y1. Okay, so chances are we're going to start with point slope form because I don't have an intercept. Then it tells me I want to be parallel. So that means same slope as this line. Okay, so can I just say, oh, the coefficient of x is 2. My slope's going to be 2 and jump right in? No, I got to put him into slope intercept form first, right? I have to solve for y. So I'm going to subtract my 2x to the other side, and I'm going to add my 4 to the other side. All right, I did two things there without really any work, so make sure you're comfortable with that. I just moved them over there to the other side. Okay, now I'm going to divide by -7. And I'm going to get a positive 2/7 x minus 4/7. That's the other line. Okay, is everybody okay with that? All right. Do I care at all about this -4/7 back here? Nope. What I want is the slope. And since I want to be parallel, am I going to change that slope in any way? No, there's my slope. Awesome. I have a point and I have a slope. Okay, that's what I'm going to use. So now I'm ready to jump right in. So first thing I'm going to find is point slope form. Okay, so that's going to be y minus y1 equals m parenthesis x minus x1. So what's x minus -8? X plus 8. There we go. First form is done. Easy enough. Okay, everybody good with that? All right, now let's go to slope intercept form. Okay, for slope intercept form, I'm going to use this one. I'm going to distribute the 2/7 and then I'm going to add the 8. Okay, so I'm going to distribute 2/7. Students get really confused when you have to multiply 2/7 by 8. But remember, you're just multiplying the tops. You're just doing 2 times 8. And then there happens to be a 7 in the bottom. So don't let that throw you. Okay, now we're going to add 8. Okay, so again, this is where the graphing calculator is nice because you can do parenthesis 16 divided by 7, close parenthesis, plus 8, and it'll fix it for you. But we can also do that. So let's see, if I have an 8/1, and I wanted to have a denominator of 7 because I want to add it to 16/7, I'm going to multiply top and bottom by 7. Then what I really have is 16/7 plus 56/7, and that gives me just a really lovely 72/7, which can't be reduced. And there's my slope intercept form. Okay. You won't have any crazy fraction work like that on the test. That's just my math lab. The test will be pretty easy little line forms. Okay. All right. Huh? 7:35?
I mean, 9:36.
I was like, what is wrong with you? Are you having a stroke quick here? Okay. Okay. All right. General form. Okay. Well, yeah, you'll have, no, like one question I want one thing, one question I want, yeah. Okay. All right. General form, we want everybody to be moved to the other side. So we could start moving them, but I really hate dealing with fractions. And remember, general form, are you allowed to have fractions? No. So let's just get rid of them now before we start having to move them around. Okay. So I'm going to write over my slope intercept form. Okay. How would I get rid of all the fractions in this case? Find the LCD. It's 7. What am I going to do with the 7? No. Got an equal sign. Got an equal sign. You want to multiply all the tops. Okay. So I'm going to get, good gracious, this pencil. 7y. Okay. These 7s are going to cancel. I get 2x. These 7s are going to cancel. I get plus 72. That is awfully nice. Okay. Everybody good so far? All right. Now we want to move everybody to the left. So I'm going to subtract both of these guys and scooch them over. I'm going to have a negative 2x plus 7y minus a 72 equals 0. Am I done? Can I circle it? I've got one issue, one little issue. General form cannot start with a negative, right? Your A cannot be negative. So either divide everybody by a -1, or you can multiply everybody by a -1. Whatever you want to do, you get the same thing. Okay, you're going to get 2x minus 7y plus 72 equals 0. And there's your general form. Okay. So either multiply or divide, and then you're good to go. Okay. Sound good? All right. We're going to start 2-5. No, just 2-5. Yeah. No, I won't overload you that far. Okay. Let's talk about 2-5. If we get through 2-5, that'll be fantastic. We'll be done. Okay. So, okay, 2-5 are transformations or translations, depending on who your teacher was when you learned it. So I learned transformation, but technically it's supposed to be translation. So I'm going to try really hard to say the word translation, but if I switch it up to formation, just know that I'm talking about the same thing here. Okay. All right. So we have to remember then how to get through all these different translations and what they mean. That's all 2-5 is. Now, if you had algebra 2, okay, you might have been scarred because you guys did translations out the hoo-ha. I mean, I know this because my daughter would sit there with those stupid IXLs doing translations forever, and they were hard. And I would be trying to help her, and I didn't even get them all right. So you are not going to be scarred in college algebra. We do little tiny, barely translations that are going to make what you went through seem so easy. Okay, so they really are not bad. But let's just go through the little chart so we remember what's going on, and then we'll jump right in and just talk about it. That's all you got to do is just kind of talk about what happened. You don't have to do anything. Okay. All right. So we know if out here on the very, very back, you have stuff added and subtracted. If something's added, you're moving up. If something's subtracted, you're moving down. Okay, vertical's wonderful. It's exactly what you think it should be. Horizontal's when it gets weird. This is the opposite of what you think it should be. Parentheses are involved. I can't even see who's doing it because there's the mask, so I can't tell who to bless. But anyway, okay. So horizontal's moving right, left or right, and it's in parentheses. So when you see parentheses, that usually means you have a horizontal. So if something is added, you're going to the left. That's kind of the opposite of what you think it should be. If something is subtracted, you're going to the right. So make sure you remember that. Okay, we do have reflections that come up every once in a while. A negative in the front reflects over the x-axis like this, just like you folded the x-axis and your graph flipped. If the negative is inside on the x, it's flipping over the y. So this is also kind of opposite of what you would think would happen. Okay. Then we have stretching and shrinking. We don't really go into this like Algebra 2 did. Well, you guys really went into that, right? We don't really do that. But if you have something multiplied to the whole thing, you're vertically stretching or shrinking. If you have something multiplied to x, then you're horizontally stretching or shrinking. Okay. All right. So here's the deal though. Order matters. This is where I think maybe in a lesson or two, the ball got dropped along the way here because not a lot of students realize the order matters. You guys get this down. You know this, but then you don't understand that they have to happen in a specific order or it's wrong. It's just like PEMDAS. If you don't do the operations in the right order, you're going to get the wrong answer. If you don't handle this graph in the right order, you're going to get the wrong translation. That's where I think there's some kind of hole missing in your high school curriculum. So we want to make sure you guys know order matters. You have to remember it. You have to do horizontal first, then you're stretching or shrinking, then you're reflecting, and then very last, you're vertical up and down. Okay, that's your order. You have to do it that way. If you don't, it's going to come out wrong. So you know we have to remember that. And you know that I always come up with something stupid to help you remember it. So here's your stupid little thing of the day. All right, so this is true story, by the way. Didn't make this up. Okay, so at Disney World, okay, you know, they have a jungle cruise. I think it's not operating right now, and they are like redoing it. But they used to have the jungle cruise. Everybody know about the jungle cruise. You get on a little boat and you float around. They're not even real animals, but it's fun and whatever. Yeah, well, yeah, they let you eat on it. So Priscilla knows. Okay. Oh, they don't. Oh, they don't. Okay. So anyway, you're on a little boat and they give you little fun facts about the animals that you would see in Africa. And so one of the facts they give you is that the number one cause of death by an animal in Africa, you would think it's a lion, right? Does anybody know the most dangerous animal in Africa that kills more people than anyone?
Yeah.
Hippos. Hippos kill more people, and I don't know why. I don't really understand that. They're you guys know all about this. Okay, so hippos kill more people in Africa than any other animal. Can we all get on board with this?
Yes.
Okay. All right. So here's your little mnemonic to remember your translations. Hippos seem really violent. Can we all agree with that? Yeah. Hippos seem really violent. Okay. Horizontal, stretch or shrink, reflect, vertical. There you go. So when you sit down to your graph, to do your graph, you just knock out a hippos seem really violent, and then you make sure that you translate in that order and you have the right graph. Easy enough? Okay, here we go. All right, so they give us this original graph. Okay, here he is. Then, and they tell us this is y equals f of x. So that's him. Then they're going to do stuff to him. It's kind of hard to see what they did, but it is f of negative x, then plus 3. That's what they did. Okay. So once they do this, they want you to pick which of these pictures it is. So here we go. Okay. First of all, hippos. Do we have anything horizontally happening here? No. If we did, you would have a plus or minus inside the parentheses, and we don't. So no horizontal. Awesome. That means we're going to stay right here. That's where we're going to stay. Okay. All right. Stretch or shrink. Okay. That means we would either need a number multiplied out here or a number multiplied in here. We don't have that either. Okay, we're not stretching or shrinking. So we are going to stay that same kind of spacing apart. Okay, reflection. Do I see a negative anywhere? I do. Okay, I have a reflection. Excellent. A negative inside the parentheses on the x means y-axis. So that's what I have here. I'm going to reflect about the y-axis. That just means if I were to fold this in half, what would happen? Okay, well, it's going to stay here. But if I were to fold this in half, what's actually, I wish I had a different color pen. Hold on, I might. Let me dig around in here, see what I can come up with. I got a little blue one. All right, so if this is going to reflect over the y-axis, I'm just going to take it the way that it is, and I'm going to turn it. Does that make sense? I'm just turning it like this. So this little hill, this little peak that's up here is going to get turned. Where's he going? To the other side. Where's this little valley that's down here going to go? The other side. So, okay, the blue didn't do a whole lot. It kind of still looks like the other thing. But that's what I did. Okay. So far, what I have done, I'm staying right here, but now I'm going boop, boop, boop. That's what I did to my original. Okay. That's my reflection, is I just turned it like this. Kind of, I messed it up using that stupid pen. But anyway, okay, there we go. All right. Now, they're also violent. So that's vertical, that's up or down. What's happening with this number? I'm going up 3. So now I'm going to take every point that you see and I'm going to move it up 3 units. That's it. All right, so which one of these guys over here do you think looks like that moved up 3 units? Hey, ta-da, there you go. Now, this is one of those, unfortunately, because we did a real simple one, that if you didn't follow the hippo seem really violent order, you still would have gotten the same picture, right? It wouldn't have really mattered. But when you get into the more complicated ones, they do. So kind of keep that in mind. But that one would be A. Okay, let's try a couple more. All right, they love this stupid little zigzag thing, so they do it a lot. Okay.
Like I said, we weren't doing stretching.
Well, just not huge. Just take a breath. They're not gigantic. I'm gonna just show you a real easy way to figure it out. Okay, so what we have here, we have 3 times f of x. That's what we've got. Okay, so hippos seem really violent. I have no horizontal movement. I do have a stretch of 3. I have no negatives to reflect, and I have no vertical movement. Everybody agree with that? All I really have is this stretch. Now, because the number's outside, if you flip back and look at the number outside, I'm vertically stretching it. So I'm going to take this little dude and I'm going to go, and I'm going to stretch it like this, right? That's what I'm doing with him. So I'm going to have a vertical stretch of 3. All that means is you're going to multiply all your y values, okay, because that's what controls vertical movement, by 3. That's why they gave you those points. That's all that means. You are still going to be confined to a domain of -7 to 7. You're not going anywhere. You're still going to have a dip, the origin, and a peak. That didn't change, right? So all you're going to do, you're going to stay right here in this same little area, but now you're going to multiply all your y's by 3. So if I do that, okay, this is a 0 times 3. It's still a 0. I stay right there. This is a -2 times 3. This is going to go to a -6. Okay, 0 times 3, I'm going to stay right here. This one times 3, I'm going to get 3, 6. 0 times 3, I'm going to stay right here. So my endpoints and my origin aren't changing. They're going to stay. The only thing that's changing is my valley is going to go 3 times lower and my mountain is going to go 3 times higher. That's the only change. So if we look at that, it can't possibly be C or B, because look what happened to them. They stretched out this way, and that's not right. I'm staying right here at -7 to +7, which means I'm either A or I'm D. Now it's kind of hard to tell, but you're going to have to try to figure out what these values are here. Okay. So I want my lowest to be -6 and my highest to be +6. And A is just a little too high and a little too low. And so your answer is going to be D. Okay. So all you have to do is multiply those y's by 3 and see where it gets you. Okay. Does that make sense? So it's not horrible. That's the worst you'd have to do. Okay. All right, let's try the next little guy. We're getting rid of the zigzaggy and we're going to get a nice little horizontal line. Okay. Okay, little horizontal line here. Here we go. This says f of x plus 2 minus 1. That's what that says. Okay. So we're going to throw up our hippos seem really violent letters. Okay. First thing I want to know is there a horizontal movement? There is. Notice it's in the parentheses and it's a +2 Excellent. So we're going left 2. So the very first thing we're going to do, okay, is we're going to scooch to the left 2. Okay, so I'm going to take this whole thing and scooch him over 2 places. So now this dot scooches over, it's going to start here. This dot scooches over, it's going to go here. This dot scooches over, it's going to go here. So I just scooted over 2 places. So that's what that looks like there. Now you don't have to do this where you do it one step at a time. I'm just kind of trying to show you that it's not horrible, right? So we scooted over 2 places. Awesome. Okay. Now there's no stretch or shrink because I don't see numbers multiplied. I don't see any kind of negative, so we're not reflecting. Is there a vertical? Yeah. And he goes down 1. So now I'm just going down 1 unit from my new little area there, and it's going to be B. And there you go. Okay, so again, that one really wouldn't have mattered. We're going to get to one that will. Hang in there. It's the next one. Okay, are we ready for the next page? Okay, this is actually our last page. We won't get through the whole thing probably, but here we go. Okay. All right. Okay, got another little horizontal line. All right, this one is going to be negative f of x minus a 4. Negative f of x minus a 4. That's what that says up there. Okay. Here we go. So, do you see any horizontal movement? Anything inside here? No. Are we stretching or shrinking? Do you see a reflection? I do too. It's right out here. Anybody remember what kind of reflection that is? The x-axis. We're going to reflect about the x-axis. Okay, so here we go. Okay. So to reflect about the x-axis, we're just going to fold it on the x-axis. So it's up here, right? Sitting up above the y. Where's it going to, or sitting up above the x, where's it going to end up? Below the x. So it's just going to scooch right down here to the bottom. Good. Okay, so he just came right down there. He reflected. Okay, now we have minus 4. Okay, so that means vertically we're going to go down 4. So now we still have to go 1, 2, 3, 4 and move him all the way down. Okay, and then he's going to end up, let's see, he reflected to a negative 2. And then if he goes down 4, he's going to end up down here at negative 5. Thank you. And it's C. Okay, so let's talk about order in this case. Okay, most students, when they see one of these, the first thing they want to do is vertical movement because it's so easy. What if you had done that? Let's look at that and see. Okay, what if you were like, I know it's going down 4. Let me just move it 4. Okay, so here it is up here at 2, at 1, a positive 1. Hold on, just watch this for a minute. It's fun. You have con today. I know you have con. Okay.
That's Wednesday.
Okay, you don't have con, but just watch it. Okay. All right. So we're going to move down 4, right? So we're going to go 1, 2, 3, 4. We're down here now. We're sitting at negative 3. Then it wants you to reflect over X where he's down here now. Where are you sending him? Woo, he ends up here. And that's why you have the choice A, because if you had done it in the wrong order, you would have picked A. Does that make sense?
Yes.
Because you would have gone down first and then reflected. You'd have been in the entirely wrong area, right? That's why it's so important that you follow your hippos seem really violent so that you get it in the right order. This one down at the bottom is going to be a huge deal too. So, okay.